Alright, so this is my assignment 3.2.1 small scale integration for asynchronous counters. Basically what we did was we're making 3-bit binary counters using D flip-flops and JK flip-flops, which I already went over in intro to flip-flops, so not going to really cover them. So basically I've got a picture here, and as you can see, we've just got 3 different basic D flip-flops for this one. This circuit was provided by the activity, so we just kind of copied this one. Basically, this is the 3-bit binary up counter for D flip-flops, so it's going to count up and upwards in binary, and it's going to display the numbers on a 7-segment display. Here's a video. It counts from 0 to 7, and that one was just kind of easy because the assignment gave it to us, so counting. As you can see, I'm not sure if you can notice, but in between some of the numbers, it kind of flickers, and that is called the ripple effect. Basically, that's just because it takes a little bit of time for the electrical current, the clock pulses, to travel, because it's spread out between 3 different flip-flops, so it just takes a couple seconds, and basically in between that time that it takes for it to get between the current to get between those 3 flip-flops, the segment, it's just going to display any number. So it's not super noticeable, but it's kind of noticeable, and it can probably cause some problems. So but for right now, it's not really a big deal. So that's the ripple effect. So anyway, with this one, we were supposed to go ahead and modify it so it will count down now. So in the first one, the major thing to kind of just note in the first one is that Q0 is the trigger for our clock, so it's linked to our clock impulse. And in order to switch the circuit so that now instead of counting upwards it counts down, we just switch the we just wire Q to clock rather than Q0, and that makes it count down. And so here's a video of that. Alright, I think that's probably as long as it was. So then we moved on to doing the same thing basically with JK flip-flops, except this time they gave us a down circuit, so it's going to count down using JK flip-flops, and here's just a video of that. You can probably still see the ripple effect. Counting down, and then we were supposed to modify it like we did the D1 to make it count upwards, and basically it's just the same thing. We're just going to have the clocks be wired to Q rather than Q0, and that just flips the whole thing and it makes it run upwards or downwards. So yeah, that's basically what we did in 3.2.1. I hope that helped a little bit. Yeah. Alright, so I realized that I said 7 segment display in the video, and it's actually not a 7-segment display, it's a hex display, and the difference between that is that it has less inputs, it only has 4, and it's just kind of like the birthday project in one little unit, because it can convert the binary into a display. You can just display a number from there. So that's what that was. And then in order to just kind of change where we start, what number we start on, what number we stop on, you can either just put inverters up by the inputs of the hex display, or down by the clears, I'm pretty sure. That way the ones up by the hex display will probably change where you're going to start, and then the ones down by the clears are going to change where it decides to reset. So that's how you do that.